In this video, we're going to write all of the trig functions in terms of the other trig functions. So it's going to be a bit of a longer one, but what we're going to do is work down through the rows of this table and we'll fill them in. So how this works is if we're looking at this cosine row, we're going to go across the table and then we're going to write cosine in terms of sine, and then in terms of cosecant, and then in terms of cosine, and we'll do that for each of the functions. We can actually start off by filling in the entire diagonal of this table, because if we're writing sine in terms of sine, that's just going to be sine. And same thing for cosecant, writing in terms of cosecant, it's just going to be cosecant. So there's not any real work to do to fill in the diagonal of this. We're also going to fill in all of the reciprocal identities, just because those are identities that we should know, that they're just like truths of trigonometry. So for instance, cosecant written in terms of sine, this is just the actual identity, 1 over sine. Same thing for writing, say, like cosine in terms of secant is 1 over secant. And like secant in terms of cosine is 1 over cosine. So all the reciprocals I've filled in here. And then we're just going to move down. So to fill in the rest of the table, we're going to need a couple tools. One of those being the general trig ratios. We know that tangent of theta is equal to sine of theta over cosine theta. Cotangent of theta is equal to cosine theta over sine theta. Cosecant theta is 1 over sine theta. And then secant of theta is 1 over cosine theta. So we'll need these. And then we'll also need the identities. So sine squared theta plus cosine squared theta equals 1, and then 1 plus cotan squared theta equals cosecant squared theta, and then tangent squared theta plus 1 equals secant squared theta. So we're going to use a combination of these identities and ratios to fill in the rest of the table. We're going to start off with sine theta, and we want to write it in terms of cosine theta. So for each of these conversions, we're going to look into our toolbox at the bottom here and figure out what identities and ratios we might need. So for this one, we could probably just use this sine squared theta plus cosine squared theta equals 1. It has both of the terms that we are looking at, and we can manipulate it to get just sine theta. So let's do that. Sine squared theta plus cosine squared theta equals 1. Then we're going to subtract cosine squared theta. That'll leave us with sine squared theta equals 1 minus cosine squared theta. And then we can take the square root of each side. When we take the square root, we need to add a plus or minus. So on the right side, it's going to be plus or minus the square root of 1 minus cosine squared theta. And this here is our first function. Now we want to write sine theta in terms of secant theta. So you see secant here, so we're going to highlight that as one tool that we're going to need. And then since secant is in terms of cosine, we're also going to need to convert from cosine to sine. So we're going to start off like we did in the previous proof. Sine squared theta plus cosine squared theta equals 1. And then we're going to solve this. I just solved it in the last part, so I'm not going to do it all out here, but it's going to be plus or minus square root of 1 minus cosine squared theta. And then we're going to bring up secant theta, and we're going to solve this for cosine. So cosine theta is equal to 1 over secant theta. Okay, so now that we have this term, we want to plug it in to this equation over here. So we can rewrite this as sine theta equals plus or minus 1 minus 1 over secant theta squared. And if we do this out, plus or minus square root of 1 minus 1 over secant squared theta. And I'm going to clean up some space. We want to basically get both of these terms over secant squared theta. So what I'm going to do, grab a smaller pencil here, is I'm going to multiply this one by secant squared theta over secant squared theta. And so when we do that, we get plus or minus the square root of secant squared theta minus 1. And then it's all going to be over the same denominator now, which is secant squared theta. This can also be rewritten as plus or minus square root of secant squared theta minus 1 over the square root of secant squared theta. And this one we can just simplify to secant theta because it's the square root of a square. So our final answer is going to be plus or minus secant squared theta minus 1 over secant theta. Now we're going to find sine theta in terms of tangent theta. This one's probably one of the more difficult conversions that we need to do, and that's because we need 3 of the identities from the bottom to do this. To start off, we need tangent squared theta plus 1 equals secant squared theta. And then we need to use this ratio to go from secant to cosine. And finally, we need this identity to go from cosine to sine. So let's see how this looks. Start off with tangent squared theta plus 1 equals secant squared theta. And we're going to rewrite secant in terms of cosine. So this becomes tangent squared theta plus 1 equals 1 over cosine squared theta. Then we're going to get the cosine squared on one side, so we're going to multiply over, and then we're going to divide by tangent squared theta plus 1. Now we can use this identity to rewrite cosine squared theta as 1 minus sine squared theta equals 1 over tangent squared theta plus 1. Then we can solve for sine squared. So I'm going to bring the sine across the other side and subtract 1 over tangent squared theta plus 1. So this becomes sine squared theta equals 1 minus 1 over tangent squared theta plus 1. And then we want to get this first term with the same denominator. So we're going to multiply this by tangent squared theta plus 1 over tangent squared theta plus 1. Now we can rewrite this as sine squared theta equals tangent squared theta plus 1 minus 1, and it's all over the same denominator, tangent squared theta plus 1. These ones cancel, and we have sine squared theta equals tangent squared theta over tangent squared theta plus 1. Then take the square root of both sides. When we do that, we need to add in the plus or minus symbol, so this becomes plus or minus square root of tangent squared theta over tangent squared theta plus 1, which we can rewrite as plus or minus theta over square root of tangent squared theta plus 1. Square of a square is just tangent, so this is going to be tangent theta over the square root of tangent squared theta plus 1. And this is sine in terms of tangent. The last item we need to solve for in the sine row is sine theta in terms of cotangent theta. And so for this one, we're going to use this identity, 1 plus cotangent squared equals cosecant squared. And then we're going to write cosecant in terms of sine using this one. And I believe that's all we need. So let's start off with the first identity, 1 plus cotangent squared theta equals cosecant squared theta. Then we're going to rewrite cosecant in terms of sine. So 1 plus cotangent squared theta equals 1 over sine squared theta. Then we will get sine squared by itself on one side by multiplying across and dividing by 1 plus cotangent squared theta. Then we will take the square root of both sides. which leaves plus or minus the square root of 1 over 1 plus cotangent squared theta. And we're going to leave this as our final answer. With that, we have solved the first row of our table. So now we have written sine theta in terms of all of the other trig functions. So the answers that we did are underlined in green here. Now we're going to move on to cosecant. Now we want to write cosecant theta in terms of cosine theta. So what I like to do is look for, first I guess, the one that we are starting with, the function we're starting with. So we have this identity here, cosecant theta equals 1 over sine theta. And then since we have this in terms of sine, we want to go from sine to cosine, meaning we're going to use this identity here. So let's see how it works. We're going to have cosecant theta is equal to 1 over sine theta. And then we want to get an equation for sine. So pulling up sine squared theta plus cosine squared theta equals 1. We can solve this for sine. Sine squared theta equals 1 minus cosine squared theta. Take the square root of each side. Sine theta is equal to plus or minus square root of 1 minus cosine squared theta. And then we can plug this in here. So cosecant, we can say, is equal to 1 over plus or minus the square root of 1 minus cosine squared theta. To write cosecant theta in terms of secant theta, we're going to need to take a few steps. So to start off, we have our ratio here. Cosecant theta is equal to 1 over sine theta. So then we have to go from terms of sine to terms of cosine using this identity. And finally, we need to rewrite it using this identity where we can convert from cosine to secant. So let's write this all out. Cosecant theta is equal to 1 over sine theta. Now we can solve for sine using this identity. And we've done this a few times before, but we'll do it again. Plus cosine squared theta equals 1. We minus the cosine squared theta from both sides. Get sine squared theta equals 1 minus cosine squared theta. Take the square root of each side. Sine theta is equal to plus or minus square root of 1 minus cosine squared theta. So let's plug this into here. We get this is equal to 1 over minus the square root of 1 minus cosine squared theta. Now we need to use this identity to figure out what cosine is in terms of secant. So secant theta equals 1 over cosine theta. We'll multiply this across and divide by secant. So cosine theta is equal to 1 over secant theta. Now we can plug this into here. So when we do that, we get 1 over plus or minus the square root of 1 minus 1 over secant theta squared. And we can simplify this a bit to 1 minus 1 over secant squared theta. And now what we want to do is get this 1 with a secant squared on the bottom. So we'll multiply it by secant squared theta over secant squared theta. And now we have plus or minus the square root of secant squared theta minus 1 over secant squared theta. In the final stretch here, now we can rewrite the bottom as, we'll just leave the plus or minus right here for now, square root of secant squared theta minus 1 over the square root of secant squared theta. This just becomes secant theta. And then since we're dividing by a fraction, we're just going to flip it. So this becomes plus or minus secant theta over square root of secant squared theta minus 1. Now we want to write cosecant theta in terms of tangent theta. So for this one, I'm going to be a little bit more clever. What I'm going to do is I'm going to take this identity here for cotangent and this identity here for secant to basically write out an equation for cosecant, and I'll show you what I mean. Cotangent theta times secant theta. If we rewrite it in terms of cosine and sine, we have cosine of theta over sine of theta times 1 over cosine theta. So when we do this, these can cancel and we're left with 1 over sine of theta, which is equal to cosecant theta. So all I'm saying is that this first part here is equal to cosecant theta. And so then what I want to do is rewrite cotangent as 1 over tangent. And then we need to figure out how to write secant in terms of tangent. So to do that, we're going to use this identity here. So let's pull it up. We'll do tangent squared theta plus 1 equals secant squared theta. And solving for just secant means just taking the square root of each side. Secant of theta is equal to plus or minus the square root of tangent squared theta plus 1. And so when we sub this in here, we can rewrite this equation that we were working on as 1 over tangent squared, or 1 over tangent theta times plus or minus square root of tangent squared theta plus 1. And what we're going to do is just put this part on top of the fraction, so plus or minus square root of tangent squared theta plus 1 over tan theta. And there is cosecant in terms of tangent. Now let's write cosecant theta in terms of cotangent theta. So for this one, I'm going to do something similar, where I'm going to be a little bit clever straight off the bat. I'm going to rewrite cosecant in terms of cotangent and secant theta. So that's going to look like this. Cosecant theta is equal to cotangent theta times secant theta. And again, I can do that because if we write these in terms of sine and cosine, we'll see that we have cosine theta times sine theta times 1 over cosine theta, and the cosines cancel, leaving us with 1 over sine theta, which is cosecant. So there's our proof. I'm going to clean that up though. Now what we want is secant theta in terms of cotangent. To do that, we're going to use first this formula here. So tan squared theta plus 1 equals secant squared theta. And then we're going to rewrite tangent here as 1 over cotangent squared theta plus 1 equals secant squared theta. I want both of these with the same denominator, so I'm going to multiply this 1 by cotangent squared theta over cotangent squared theta, which gives us 1 plus cotangent squared theta over cotangent squared theta is equal to secant squared theta. Then we're going to take the square root of each side. So let's actually move this up. This is going to give us secant theta is equal to square root of 1 plus cotangent squared theta over cotangent theta. So the square root and this square cancel out. And then we can plug in this into here. So when we do that, we get cosecant theta is equal to cotangent theta times square root of 1 plus cotangent squared theta over cotangent theta. And the cotangents are going to cancel. And actually, when we took the square root here, we need to add a plus or minus. So our final answer is cosecant theta is equal to plus or minus the square root of 1 plus cotangent squared theta. Now we have completed the second row of our table here for cosecant. So all the ones we just solved for are underlined in green here. And now what we're going to do is move on to cosine of theta. To write cosine theta in terms of sine theta, we just need to use one identity here. So how we can do this is we can rewrite the identity sine squared theta plus cosine squared theta equals 1. Solving for cosine, we'll have cosine squared theta equals 1 minus sine squared theta. Taking the square root of each side leaves us with cosine theta equal to plus or minus square root of 1 minus sine squared theta. For writing cosine theta in terms of cosecant theta, we're going to use this ratio here and this identity here. So the first step is going to be to get sine alone. So we're write cosecant theta equals 1 over sine theta. We're going to solve this for sine, so this becomes sine theta equals 1 over cosecant theta. Now we're going to use this identity and replace sine squared theta with 1 over cosecant squared theta. So I'll just write it all out. Sine squared theta plus cosine squared theta equals 1. This is going to become 1 over cosecant squared theta plus cosine squared theta equals 1. Then we're going to get cosine by itself, so cosine squared theta equals 1 minus 1 over cosecant squared theta. We want like terms on the bottom, so we'll multiply this by cosecant squared theta over cosecant squared theta. Cosine squared theta equals cosecant squared theta minus 1 over cosecant squared theta, and then we take the square root of both sides. So in the end, cosine theta is equal to plus or minus square root of cosecant squared theta minus 1 over cosecant squared theta. You could also write this as by like separating the square root, so it's square root of this over square root of this, and this lets you simplify it a little bit more into plus or minus the square root of cosecant squared theta minus 1 all over cosecant theta. So that looks a little neater. To write cosine theta in terms of tangent theta, we're going to use this identity here and the ratio for secant theta, which is 1 over cosine theta. Really what we're going to do is just plug this ratio into this identity. So let's see how that looks. We'll have tangent squared theta plus 1 equals secant squared theta. And then we're going to replace the secant squared theta with 1 over cosine squared theta. Now we're going to solve for cosine. So we're going to multiply the cosine squared over and divide by tangent squared theta plus 1. Then we're going to take the square root of each side. So we get cosine theta is equal to plus or minus square root of 1 over tangent squared theta plus 1. Then we can rewrite this by breaking up the square root into plus or minus. This is just going to be 1 on top over the square root of tangent squared theta plus 1. And this is our answer. There are a few different ways to write cosine theta in terms of cotangent theta, or a few different processes you can go through. The one I want to show you involves using cotangent directly and multiplying it by sine. So let me show you what I mean. Cosine theta is going to be equal to cotangent theta times sine of theta. And so just to prove this out, if I rewrite cotangent in terms of cosine and sine, I get cosine of theta over sine of theta times sine of theta, and these cancel, and we just have cosine. So there's the little proof. Now we want to write sine in terms of cotangent, so we can use this identity. And how this looks is 1 plus cotangent squared theta equals cosecant squared theta. And I forgot one other thing I need to highlight is we're going to use this ratio and plug it into this identity. So this equation up here becomes 1 plus cotangent squared theta equals 1 over sine squared theta. And then we can solve for sine. So we'll bring the sine squared over, divide by 1 plus cotangent squared theta take the square root of each side. Sine of theta equals plus or minus. I'm going to get rid of the square root on top, and we're just going to have square root of 1 plus cotangent squared theta. Now we can plug it in over here, and we'll have cosine of theta is equal to cotangent theta over plus or minus the square root of 1 plus cotangent squared theta. At this point, we could fill in the rest of this table without doing any more difficult math. And the reason we can do that is that we know what the ratio of these remaining trig functions are in terms of the functions that we've already solved. So for secant, we know that it's 1 over cosine theta. So all we would need to do would be to find cosine theta in this column and then do 1 over it. Same thing for tangent. We know that it's sine theta over cosine theta. So we could just reach back up in the column and get sine theta, put it over this cosine theta, and we would have tangent theta in terms of sine. For the sake of completion, though, I am going to run through all of the steps for getting these, but if you want to stop early and fill it in, you can do that. Now let's move on to secant theta. So we want to rewrite secant theta in terms of sine theta, and to do that, we're going to use this ratio here and this trig identity here. So to start off, we're going to have secant theta equals 1 over cosine theta. So let's solve this for cosine. We'll have cosine theta equals 1 over secant theta. And then we're going to plug it into this identity here. So we'll write the identity out. Sine squared theta plus cosine squared theta equals 1. And then we're going to replace cosine squared theta with 1 over secant squared theta equals 1. Okay, so now we want to solve for secant. So we're going to subtract the sign across. We're going to be left with 1 over secant squared theta on the left equals 1 minus sine squared theta on the right. Then we're going to multiply this here and divide this. So we're doing a little bit of movement around, but what we have left is secant squared theta equals 1 over 1 minus sine squared theta. And then we want to take the square root of each side. So coming over to the left here, we're going to have secant theta is equal to plus or minus the square root. I'm going to leave the top as just 1, and it's going to be over the square root of 1 minus sine squared theta. To solve for secant theta in terms of cosecant theta, we're going to use this identity here, which has secant in it, and then this one, which connects cosecant to cotangent. So let's write out what we have. We have secant squared theta equals tangent squared theta plus 1. Then I want to rewrite tangent as 1 over cotangent. So this is going to be secant squared theta equals 1 over cotangent squared theta plus 1. And I want to get like terms here, so I'm going to multiply this by cotangent squared theta over cotangent squared theta. We can rewrite the entire thing as 1 plus cotangent squared theta over cotangent squared theta. And this top part we see is this identity. So now we can rewrite this as secant squared theta equals cosecant squared theta over cotangent squared theta. So now we just have to rewrite this identity here and solve for cotangent. So 1 plus cotangent squared theta equals cosecant squared theta. And then cotangent squared theta is going to be cosecant squared theta minus 1. So we're going to replace this bottom part with that. Cosecant squared theta minus 1. Finally, we take the square root of each side. Secant theta is equal to plus or minus. On top, the square and the square root are going to cancel, so this is cosecant theta over the square root of cosecant squared theta minus 1. To write secant theta in terms of tangent theta, we really just need this one identity here. And all we're going to do is solve it for secant. So let's write it like this. Secant squared theta equals tangent squared theta plus 1. Take the square root of each side. Secant theta is equal to plus or minus square root of tangent squared theta plus 1. And that's it. To write secant theta in terms of cotangent theta, I'm going to use this ratio for cotangent theta and this ratio for cosecant theta. And I'm going to write secant theta first as cosecant theta over cotangent theta. So this is a tricky little start, but if we rewrite these in terms of sine and cosine, we get 1 over sine theta over cosine theta over sine theta. And because we're dividing by a fraction, this is going to cancel out, and we're just going to be left with 1 over cosine theta or secant theta. So that's the proof on the right there. I'm going to get rid of it. But then what we need to do is figure out what cosecant theta is in terms of cotangent. So luckily we have this identity here, so we can solve this one for just cosecant. So let's do cosecant squared theta equals 1 plus cotangent squared theta, square root of each side. Cosecant squared theta equals plus or minus the square root of 1 plus cotangent squared theta. And, oh, when we squared it, we got rid of that. And then what we're going to do is plug this in here. So secant theta is equal to plus or minus the square root of 1 plus cotangent squared theta over cotangent theta. With that, we've completed the row for secant theta, and the ones underlined in green are the ones we just solved for. So what we're going to move on to next is tangent. To write tangent theta in terms of sine theta, we're going to need this ratio here and this trig identity here. So let's write out the equation for tangent, which is sine theta over cosine theta. And we want all sine thetas, so we need to get cosine theta in terms of sine. So that's where we're going to use this identity. So let's write it out. Sine squared theta plus cosine squared theta equals 1. Now we're going to solve for cosine. So cosine squared theta equals 1 minus sine squared theta, square root each side. Cosine of theta equals plus or minus square root of 1 minus sine squared theta. And then we're going to plug it in here. So then tangent theta is equal to sine of theta over plus or minus square root of 1 minus sine squared theta. To write tangent theta in terms of cosecant theta, we can basically just use this one identity here. And how we can do that is, let's write it out. 1 plus cotangent squared theta equals cosecant squared theta. And then we're going to replace this with 1 over tangent squared theta. Oops. Okay, now what we want to do is just solve for tangent. So let's subtract the 1 across. Do 1 over tangent squared theta equals cosecant squared theta minus 1. Then we'll multiply this side by tangent squared theta, and we'll divide the other side by cosecant squared theta minus 1. So what this is going to look like is tangent squared theta equals 1 over cosecant squared theta minus 1 square root tangent theta is equal to plus or minus square root, I'm going to leave 1 on top by itself, over the square root of cosecant squared theta minus 1. To write tangent theta in terms of cosine theta, we're just going to use this identity here and this ratio to go from secant to cosine. So what I mean by that, let's write this out. Tan squared theta plus 1 equals secant squared theta. And then we're going to rewrite this as 1 over cosine squared theta. So filling the rest of the expression back in, we get this. And now let's solve for tangent. So we're going to subtract 1 here. Tangent squared theta equals 1 over cosine squared theta minus 1. Then we want like terms on the top and bottom. So let's multiply this by cosine squared theta over cosine squared theta. This is going to give us 1 minus cosine squared theta over cosine squared theta. And then we can take the square root of both sides. So tangent of theta is equal to plus or minus square root of 1 minus cosine squared theta over cosine squared theta. And we can further simplify this into the square root of 1 minus cosine squared theta over cosine theta. To write tangent theta in terms of secant theta, we just need to use this equation here, and we need to solve for tangent. So let's do that here. Tangent squared theta plus 1 is equal to secant squared theta. Then we're going to subtract the 1 to both sides. Tangent squared theta equals secant squared theta minus 1. Take the square root of both sides. Tangent of theta is equal to plus or minus square root of secant squared theta minus 1. With that, we have completed the tangent row. So these are the equations that we just figured out. And now what we're going to do is move on to cotangent. We can write cotangent theta in terms of sine theta using this identity here. So we'll bring it up to 1 plus cotangent squared theta equals cosecant squared theta. And we're going to rewrite this as 1 over sine squared theta. Fill in the left side here. And then let's solve for cotangent. So we're going to subtract a 1. Cotangent squared theta equals 1 over sine squared theta minus 1. And we're going to multiply this 1 by sine squared theta over sine squared theta. So this right side becomes 1 minus sine squared theta over sine squared theta. And then we're going to take the square root of both sides. Cotangent theta is equal to the square root of plus or minus of 1 minus sine squared theta over sine theta. So what I did was I just, this was a square root and I just got rid of it. So final answer is here. To write cotangent theta in terms of cosecant theta, we have an identity here with all of the good parts that we need. So let's see what we can do with it. Cosecant squared theta. And so now let's solve for cotangent theta. We're going to subtract the 1, subtract the 1. Cotangent squared theta equals cosecant squared theta minus 1. Square root of both sides. Cotangent theta equals plus or minus square root of cosecant squared theta minus 1. Easy peasy. So to solve cotangent theta in terms of cosine theta, we're going to need this ratio here and then this identity here to get sine in terms of cosine. So we can write this out. Cotangent theta is equal to cosine of theta over sine of theta. So this cosine on top is good, but we need to get this sine in terms of cosine. So we're going to use the other identity, sine squared theta plus cosine squared theta equals 1. And we're going to solve for sine. So subtract this across. Sine squared theta equals 1 minus cosine squared theta. And then we're going to take the square root. Sine theta is equal to plus or minus the square root of 1 minus cosine squared theta. Alright, then we're going to plug this in here, and finally we get cotangent theta is equal to cosine theta over plus or minus the square root of 1 minus cosine squared theta. Beautiful. So to write cotangent theta in terms of secant theta, we're going to use this identity here, and we're just going to replace that tangent squared with a 1 over cotangent squared. So I'll write it all out. Tangent squared theta plus 1 equals secant squared theta. And then we're going to replace this with a 1 over cotangent squared theta plus 1 equals secant squared theta. So now we want to solve for cotangent squared. So we're going to subtract 1 here, get 1 over cotangent squared theta equals secant squared theta minus 1. Then we're going to multiply this up and divide this down. So this becomes cotangent squared theta equals 1 over secant squared theta minus 1. And the last step here is just take the square root. We get cotangent of theta is equal to, we're going to leave the 1 on top by itself, 1 over plus or minus square root of secant squared theta minus 1. And with that, we have completed our table. So we just solved all of them for cotangent theta. These are the ones we just did. And now we could use this as a reference for solving a bunch of other trig problems.